Hello class, this is Mr. McAllen working on question 4, and in this question they're asking us to uh, graph the function showing all asymptotes, those that do not correspond to an axis, as dashed lines. List the x and y intercepts. So let's find the x and y intercepts first. So x intercepts are found by plugging in or setting, I'm sorry, x-intercepts are found by, for a rational function, setting the numerator equal to 0. So my x-intercepts are going to be, in this case, this is very easy. X minus 1 equals 0. So x equals 1 will be my first or only x-intercept because that's the only value which will be an x-axis crossing. So finding my y-intercepts, these are should be more basic operations because a y-intercept is where you just, when you're at the y-axis, that's where the x-coordinate is equal to 0. So you simply plug in x equals 0 into your function, and you find out in this case that it's the y-intercept is going to be at y equals negative. The top would be -1. The bottom would be, this would be 0. This would be 0. You have -4. So your y-intercept is going to be at 1/4. So our graph here is really teeny tiny. So I'm going to make it a little bigger, more so you can see it. So I have my x-intercept at 1. And if you feel the same way on when you're taking the test, do the same thing, draw another graph and just label this like this is, 0 comma 1/4, and this is 1 comma 0, and use pencil. So in case you have to erase, you can do that. Now, let's work on our equations of vertical asymptotes. Vertical asymptotes are always found in the bottom, and we'd want to factor that bottom equation. So x squared minus 3x minus 4. When we factor, set that equals 0 and solve, we factor it. We have x minus 4x plus 1. Simple factoring from algebra 2. And you set these equal to 0, and you find out that your zeros for your denominator, which would be your asymptote equations. X equals 4, so I'm going to go over to 4. 1, 2, 3, 4. I'm going to draw my vertical asymptote there. I'm going to label it. Please don't forget to label it. We want you to get full credit. And at -1, your asymptote here. So that's x equals -1. And then we're going to look for our horizontal asymptotes. So remember, horizontal asymptotes, we had a method for that. You should write that method down from your notes on your note card. But when the degree of the rational function was less than 0, then your horizontal asymptote equation was always y equals 0. In this case, the degree of the top is 1, because that's a power 1. The degree of the bottom is 2. So that means that the overall degree of the rational function is going to equal, is going to be -1, which is less than 0. So the horizontal asymptote will be at y equals 0. So I'm going to do that. I'm going to make that in red. So this is the horizontal asymptote at y equals 0. And because we had a degree that was less than 1, or less than 0, I should say, we do not have any slanted asymptotes. Now remember, if the degree equals 1 of the rational function, you have to do long division to find your equation of your slanted asymptote. So make sure you look that over because you never know, that may show up on the midterm. I mean, we want to make sure you're prepared. So now we want to sketch this. So in sketching this, you can plot as many test points as you like. So I like to plot using the original equation. I'm going to just rewrite the original equation. I have x minus 1 over x squared minus 3x minus 4. So I'm going to plot a test point over here at, like, let's say -2. And when I put so I'll do f of -2, and I get -3 over, when I plug -2 in the bottom, I get 4, because -2 squared is 4, plus 6 minus 4. So I end up getting -1/2. Well, -3 over 6, which is -1/2. So that tells me that below the x-axis, and because I can't have any other zeros over here, I know that the function has to look like this. Pardon me. Now I'm going to do, I have these 2 points in here, which tell me the function is going to do something like this. I know it's crossing through this at this point here because it's a single root in the top. It's not ordered to. It's not going to have a bounce, because if it was like x minus 1 quantity squared, you would see bouncing where it would head back up above the x-axis. But because it's only to the first power, that root at x equals 1 is going to be a through root. So on the last one, I have to use it, and you can use as many test points as you like. There's no restriction on how many test points you use. So please use as many as you like to give you confidence that you got the graph. So then you have f of 5, and I'm going to plug that into this function. So that'll be in the top, you'll have 5 minus 1, which will be 4. In the bottom, you'll have 5 squared minus 3 times 5. I'm writing this out so I don't make a mistake. It's really early, and just don't want to make a simple mistake here. We got 4 over, it's going to be 25 minus 15 minus 4, which gives me 4 over 6, which will be 2/3, which tells me that it's a positive value. So the function has got to look something like this. It cannot cross through the x-axis, because I only have 1 0 that I found, and that was right here. So that's how the function looks. You can verify this with Desmos, like if you're practicing, but hopefully this video has helped you help refresh your memory on how to plot these rational functions.